Very happy to be here. Hello, everybody. Back in Montreal. Super happy. I just gave this talk yesterday, so chances of me screwing up was slightly less high. Slightly. All right. So I'm Étienne. A lot of you know me. Hello to all the new people. I'm very happy to have new people here. It's really awesome. Today I'm going to talk about Coroutines, the flow, and the MVI architecture. Right? You like how that animation went? Like, you might recognize Mural from the Mural Festival in Montreal. If you have like blue or red, those kind of filters, you can check out that Mural. It's really awesome. All right. So, oh yeah, I have to say thanks to a few people that allow me to go and speak all around the world and stuff, because that's really, I'm really thankful for that. So Shopify, my employer, is very good with that. And the Google GE program is also really awesome for supporting people like me who like to speak at conferences, do blog posts, although I'm like the least regular blog poster ever, but hey, whatever. They're very supportive, and a big thank you. All right, with that out of the way. So, I personally first discovered the MVI pattern a few years ago. It was on Hannes Sorkin's blog. You can see the URL there. So the general idea of the MVI pattern is that you have a view. That view generates UI events when your user presses buttons and changes text and text fields and things like that. You turn those into intents. So what is the idea behind intents? Their intents are actions you want to apply to your model being your state, right? So if you're editing your first name, you'd expect that to turn into a change first name intent, which would be applied on your model. So, cool. What's so special about this anyway, right? That sounds pretty straightforward. There's a few key features of MVI. So the first big one is that it relies strongly on functional programming principles. So if you think of mathematics, functions have a few important properties that you want to carry over into your programs. So I'm putting it very simply here. Think of calling a function with a given value x, right? You're expecting to return a value y, and hopefully if you call that function with the same value again, you'd expect the same result, right? That'd be nice. You don't want it to change. And the corollary to that is that you also don't want it to do side effects on your program. So when you're calling a function, you're mutating something in the background, and that changes over time, that can get bad pretty quickly. So you don't want that ideally. In mathematics, when you call a function, nothing else weird happens in the hidden zone of mathematics, right? Like you just get a value back and that's it. So those sound very simple principles that I'll just see, and they're kind of interesting. So a nice way of getting rid of side effects is to adopt immutable values. So in object-oriented and functional programming, an immutable value, pretty simply, is something that will not be changeable once you created it. So if you assign value 2 to an immutable variable, it won't change. You won't be able to go back and just switch it around. So that's in contrast to an immutable thing, which you can change, which has also important properties that you do want sometimes in your program. But mutables are kind of dangerous, right? If you're thinking of an object that has a couple of fields like first and last name, and you're passing that around, somebody comes in and changes it while you're trying to display it to the screen, race conditions will occur and nasty things will start happening in your program. So immutability is sometimes something you expect to be there, and when it's not there, it's going to crash your app. So if you can actually enforce it, that's a good thing. You're going to make your apps more solid. Right. Another key MVI feature is that it relies on the active programming principles. So the nice thing with that is that it allows you to break down complexity. You can focus on one problem and one task at a time, and then reactive programming usually allows you to recompose your logic in super interesting ways. So you're going to have to take my word for it a little bit. As we go further into the patterns, you might see where those ideas apply and they come up. So, my personal stack of choice for reactive programming for years now has been RxJava. I like how it allows for safe parallelization of work. I managed to say the word parallelization without something too much. I'm very happy with myself right now. It also allows you to, it also gives you a very powerful API to manipulate streams of events. So you can do stuff like control over which thread certain things are going to be fired off and which thread things will come back. So if you think about a network request, that's super practical, right? On Android, for example, or even other UI frameworks, you want your UI updating to happen on one thread, the main UI thread, and you want your network slow stuff to happen somewhere else if you don't want that to block your main thread. Right, so RxJava is really useful that way. You can do all sorts of manipulations of threads and throw jobs left and right and rejoin them. So it's a really nice library for that kind of thing. It does come with a few caveats though. So hefty learning curve. Who here knows RxJava uses it daily in their work projects? So that's like, I want to say 10% of the audience really. Right? So depending on which conference you go, the hands are raised a little bit more. But in my experience, like a lot of places are really shy about adopting it because it's complicated. Like before you can make sense of it and actually use it in the proper way and not get a ton of crashes, you need experience with it. So it does seem like witchcraft most of the time. The barrier entry is enough to discourage a lot of shops from adopting it, so that's what happens. The library size is around 1.5 meg. So that's not terrible. Like if you think about it, I think the stats are that the latest web page you're going to download off the phone is like a meg. Which is funny because when I started it was like 32 Ks. But 1.5 meg is actually a significant size. So if you know about instant apps, making an instant app on Android has very specific size limits. And 1.5 is enough to bring you over. So wouldn't it be nice if something a bit smaller with the same properties was available? That could be cool. Right, so the other thing is that life management becomes a challenge in RxJava fairly quickly. So none of that's too small for most of that. Hopefully, I can change it. Alright, so what you can see here is that when you want to manage subscriptions in RxJava, it's fairly simple. You create subscriptions, you need to add them to this compose to disposable type object, and at some point in the life cycle of your app, you're going to need to clear that stuff, and that's going to stop everything. It's not terrible. But if you start thinking about, I don't know, one subscription per UI element, and complicated life cycles, it's in pause and resume. Do I want to update that field? Is it going to be visible on screen or not? But if you start messing around with that stuff, you quickly get into a situation where your subscriptions might run out of control. Like you might not shut them down at the right time. You're going to have a lot of them. So that can become challenging. Right? Does that mean anything to you, that reference? Like, you guys get the special ones. I took it out of the deck I did yesterday. I was too shy. The tame catch, so, right? So, coroutines and flow. So, coroutines and flow as a replacement for RxJava or as a full-fledged reactive library. So, what are the advantages there? So thanks to coroutine scope and structured concurrency principles, the story that you're going to get around the lifecycle management I just mentioned is really good here. So if you're not familiar with the main structured concurrency principles, if you go read Roman Elizarov, I keep looking at his last name, but he's one of the main developers in coroutines at JetBrains, and he has a few nice articles that talk about the structured concurrency principles and links to another bunch of really nice articles where they make this basically this comparison with the old goto operator we used to get in the 80s and early 90s. So the thing with goto, why it was so evil, was not that it was a non-necessary construct. You could basically do very nice loops with goto, but you ended up building stuff that we now know as for loops and while loops. Like if you didn't sort of follow a certain pattern of goto, you'd shoot yourself in the foot really, really quickly. And goto was very agnostic. It could let you do anything you want, right? So if you think about that as being the problem why goto is such a nasty operator, if you think about asynchrony in general, a lot of what we do, like futures and things like that, none of them enforce in any way a contract that says, hey, I have to sort of, you reach a point in your program, you launch a new process, you basically have two things running at the same time. And one of them doesn't really have anything that says, oh, I have to come and join back to what the parent that started me to sort of say what happened. Like futures don't force you to do that. And in a way, they're very similar to gotos. So structured concurrency is the concept that there are primitives that are introduced in coroutines that sort of don't allow you to just spin off things that will never come back, in theory. So that's the concept. That was a bit of a long-winded explanation, but I felt like it was worth it. Alright, so that concept helps us a lot with the lifecycle management because it's very hard to actually forget the shutdown stuff, is what I'm getting to. Cool. Weight-wise, very quick, it's actually 150K, the two of those jars combined. So That's pretty cool. Wizard refactor. So they're kind of very new coroutines, and Flow is also super new. A lot of the stuff in this deck, well, it was almost outdated because something came out like 3 days before my talk. And I have a few things to show you at the end that are already outdated because the new library came out like another couple of days ago while I was writing the deck. So they're very new. It's still kind of wizard work. So the thing I want to sort of pitch to the audience a little bit is that whenever you learn wizardry, you gain a new superpower of sorts, right? People like saying that. So the real question is more, what's the return on the investment when I'm going to learn something hard, right? And is it going to be worth it? And is that knowledge going to serve me everywhere? Even in places, like say, that you work in a place where not everybody wants to learn new stuff all the time, right? They just want to be productive, and that's like a very noble thing. You don't always want to be learning the cutting edge crap. Like some people are just like, just let me work, please. What? Coroutines? I'm just using this. No. But that's fine. The thing is, with coroutines and Flow, they're part of the language. So any shop that adopts Kotlin will eventually, in one way or another, have coroutines available in their programs. And it's kind of inevitable that at least some people at the shop that's using Kotlin are going to have to know how this stuff works. So I think the return on investment here is a lot better than RxJava in a lot of ways. Time will tell. All right, so onward to more practical stuff. Getting back to reactive programming as a concept, I'm going to go very, well, not too quickly, but I'm going to try to go quickly enough. Reactive concepts and tying it to an MVI architecture. So reactive programming is concerned with data streams and the propagation of change. So what does that actually mean for an app developer? So if you think of a mobile app as a reactive system, you have an app that renders stuff to the screen, right? The user is going to look at it, and then their brain is going to go, what did I just see, right? Like if you think of the user as a function, that's the parameters, like the actual thing I'm seeing in front of me, like a variable coming in, and the user is the function. A very random function accordingly. I don't think like if you call the user twice on the same screen, I'm not sure they're going to answer the same thing, but hey, whatever, right? So the user is going to do something with your screen and press a button, or dismiss a dialog, or other stuff. That's going to become an input, it's going to come into your app's going to react to that, right? React, and update itself, and so on and so forth. So this is kind of the idea behind the reactive model. Fairly straightforward if you think about it. So if you translate that to MVI and start putting UML boxes all over the place, you can think of the view as a placeholder for the user, right? Because that's what the user interacts with, that's what the user looks at, and that's what's going to generate view events and things that are going to come in that you're going to have to deal with. So once you start getting something called, like that we will call view events, you want to translate those into something we're going to call intents. The idea behind intents is that they are work that will be processed and applied onto the model. And once you take an intent, apply it to the model changes, you want those changes to be basically pushed to the view when relevant, so that the view can update itself, and that the user can interact with it again. So if I dig in a little bit and have like a very concrete example of this very abstract stuff, this is a sample app, and we call it upvote. I've called it upvote, it's called upvote. So in this app, when you press a button, it's going to increment a hearts or thumbs up counter. So whenever the user presses a button, it's going to emit what I call the view event right now. And that's going to trigger that whole chain I've been mentioning, the intent to model to view loop, and our screen counter gets updated. Cool. So if I press it again, it goes up by 1. So let's actually look at what our view is sending exactly. So to keep things nice and tidy, these are the kind of events that our view is going to be able to emit. So here you can see I've used a sealed class, and I've used singletons effectively, right, by using the object keyword here, because those events don't carry any payload data, right? They just happen, and you're going to do something about it. So we have a thumbs up click and a love it click. So now we're going to start, well, not right away, but today we're going to be using Kotlin Flows, right, to generate asynchronous streams of values. And what I'm going to be doing going forward is I'm going to steal an RxJava convention, which I find super useful for visualizing type of screen, and it's called the marble diagram. Who's here familiar with marble diagrams? So who here finds marble diagrams kind of scary? and that's a fair thing. So they're less scary because I animated them, trust me. All right, so if you think of the view as a flow of events, this is a normal diagram. Every time the user presses a button, we want a new view event to be emitted by that flow. It's written observable here, but it's a flow. I almost stripped it out, and then I just let everybody know. It's terrible. I'm going to freeze for a second here. All right, so how do we build a flow of view clicks when clicks are callback based? Right? If you know your Android, you're going to set a listener to that view button. That's like a very old school thing. So how do you turn that into a flow? There's a few ways you can do that. I'm going to show you one of them, and I'm going to tell you about a second one at the end of the talk. So right now what I've used is callback flow. So this is a builder function that Kotlin gives you. It's part of, I think, the channels APIs. So when you have a callback flow that allows you to, well, it's a bit of a mix of channels, if you know what those are, and you might know a bit more by the end of this presentation, and flows. So when you call a callback flow, your Lambda is going to be operating in one of those channels. And channels are things that you can send data over, right? So that's going to be useful. So once we call the callback flow, what we'll do first in that block is we're going to set our view's click listener. So we're just going to be doing one thing. Whenever the view is clicked, we're going to offer a unit. So if you know Kotlin a little bit, a unit is almost like a void, except it's something that you can pass around. So why are we passing this weird little non-object of an object? Well, effectively, a click is just an event, right? It doesn't carry any payload, so unit is perfect for this. Whenever a unit is offered onto the flow, it's basically going to say something happened. We're going to need to decide what that means later. So we assign that listener to the click listener, and we need to do one more thing. So we call await close before being done here. And the reasoning is that whenever you set up a callback flow, if you wouldn't be doing this, it would, whenever you sort of start subscribing to this flow, it would run through the code, assign the listener, and stop, and it wouldn't emit anything. So this being a coroutine setup, the little icon that you see where the arrow is squiggly bit, that's to signal that there's a suspend function going on right there. So what's going to happen when you call await close is that the flow that you've instantiated is just going to stop and then wait. What is it waiting for? It's waiting for the either of two things, that the collector, the subscriber, is canceled, and then it's going to actually complete, set the click listener to null and leave. Or it's also waiting for somebody to close the backing channel, which is something we're not going to get into here because it's not relevant to the talk. But that's two ways you can use callback flows. So that's a bit complicated if you're new to coroutines, but the thing to remember is it's the way to bridge coroutines, channels, and flows with your original listener-based Android world. So this kind of approach is going to work effectively for almost all kinds of buttons and text views and so on and so forth. Now, I'm gonna give you guys a spoiler right away. There's a library that does this now. It's doing it almost the exact same way. I originally cribbed this approach from somebody called Zach Swears, who's an ex-Uber engineer. I think he worked at Path before that. Pretty well-known guy in the community. So he had a little GitHub of that stuff. I cribbed it off of him, but then somebody came up with a library that effectively writes all of these kind of operators for all-hand widgets, and then all your widgets can turn into those flows that I mentioned. Thanks to that library, which I'll give the link to at the end of the talk. All right. So now we have a coding pattern to turn an Android view, like a button here, into a flow. All right. So we're going to need to do something about those clicks. So the first thing we do with this flow is that we create it by calling our view with the extension function clicks. That's going to give us a flow of clicks, right? So that we can see that at the top. So anytime somebody clicks, that's going to send something into the flow that we can handle. The goal, though, here is not to have like a flow of unit clicks. We want main view events, right? We want these upvote events, or or upvote or upheart events. So if we take the thumbs up button as an example, I'm going to take the actual thumbs up view, click the button. I'm going to call clicks on it, so that new extension function I defined earlier. So then I get a flow of units. And then what I do is I map that flow of units to my event, my main view event thumbs up clip. that means that whenever that button's going to get clicked, this is the event that we're going to get. We suddenly now have a flow of thumbs up click, right? So whenever that happens, we take the unit, we turn it into an actual event, and we're good. And we're going to be doing much of the same thing with the hearts button, as you probably already guessed. So we're going to create another flow, and that flow is going to be a flow of button clicks. Whenever that gets clicked, something's going to happen, right? That new event is going to be emitted. Cool. So now, what we want, though, is not two flows of individual buttons. Like, to handle things in a nice way and make things easy, right? So if your screen has 10 buttons, you kind of want to have only one flow. And you want that flow to be a flow of main view event in this case. If your screen is edit user account screen, then you want the edit user account view events, right? And then that's going to, per screen, you're probably going to want to collect all of those into one flow so that you can handle them a bit easier and not have a ton of boilerplate all over the place. So the trick is that you want to take two flows and flatten them into a single one. This is how we're going to achieve that. So what this looks like in the main activity right here is that we're going to create this view events function, and that's going to return our flow of main events. And then the first thing we're going to do is creating a list of these flows, just a plain old list, a collection. So once we have that, then we can start messing around with it a little bit. So Kotlin Flow extensions and Flow APIs give you this extension function as Flow that works on almost all collection types. So that can take a collection type and turn it into a flow. Once you have that, here we have a flow of flows, which is a bit special. So what we want, though, is a flow of a certain type of events. So what we do next is called this flatten merge function. So that one, we give it a parameter, we tell it how many concurrent flows we want to be basically broadcasted into this one pipe. So in this case, effectively we want it to be the exact same size as all the sources. So by doing this, we've created a single channel that when we activate it, every time somebody clicks, those events are going to be converted and they're going to be sent out of the pipe. So it allows us to take a lot of sources and turn them into a single one. Alright, so that's how we can merge different flows. Now to make things a bit more formal, I like to create interfaces. That's really just a convention here. So by doing this, anytime I have a view component, a view group, or an activity or something like that, I effectively can say, this component only has one output point, and that output point is a stream of stuff. So what's nice about this approach is that that stream of things, conceptually, you can subscribe to it and declare a block of code that's going to run on every bit that comes out, and that effectively allows you to really easily connect components together, right? So if we want to start thinking about how we're going to use these and send them over to our next layer. So I talked about lifecycle earlier. With coroutines, we have something called the coroutine scope. So a coroutine scope, it has a certain lifecycle of its own, right? When it's started, then you add coroutines into it. You start coroutines and basically keep track of all of those. You always need to be within a scope when you start a coroutine, so that's handy. You can't really create one unless you have a scope. And when you're done with your scope, you call cancel on it. So here what's interesting is that you have control over when you start and stop this thing. So here I have a very naive life cycle, right? I just want it to go away when the activity is destroyed. But if you want that to be something more like the view model life cycle, you can move the scope creation and destruction, or canceling, sorry, into a view model in the right appropriate lifecycle functions. But right now we're going to keep that simple, so that's all we need to do. So next up, we want to start thinking about where we're sending these events. So this is how you start coroutines, right? You use the scope launch, so you use the launch function on the scope, and then in that block, you can start having suspending function. What's going to happen here is that when you launch this, it's going to run in line. Whenever it's going to hit the suspend function, that's going to run off on its own. It's not going to block in any way your activity, right? You're going to do scope launch, as far as the activity is concerned, it's just going to keep going. And that other coroutine is going to do its own thing. Right. So the thing to note here is that whenever you call collect on the flow, if you didn't have a launch function around this, what would happen is you could try to do this on create, but then the view events would be called. It would create a flow of view events. You'd do something with each of these events coming out. You'd call collect. What would happen then is that collect is going to suspend until everything is selected, right? And that's going to be forever. So that doesn't work. So what you want to be doing is launching it on the side, and then when you call so cancel on it eventually, that's going to stop that coroutine for you and cancel it. Alright, so let's focus on what happens to each event when we send them out. Clicker. Alright. Okay. Another way of doing exactly what I just did, to just simplify the boilerplate a little bit, is you use the launch end function at the end of your flow. So this is going to do exactly what I just showed you. Instead of having a scope launch that wraps the thing and then have the flow in there, you can call launch end, give it a scope, and that's actually going to do the same thing. It just keeps the code tidy, right? So now let's focus on what we want to see on each. So on each is going to be called once for each event that comes out. So every time the user clicks, this is going to be called. So what are we going to do? We're going to take each of those view events and send them to something I've called the main view intent factory here. So the idea is that you take the view events, you create intents out of them, and you need something called a factory to do that. And we're going to start focusing on what happens exactly in this factory, in this layer. Alright, back to the diagram, so just so people keep a little bit in mind where we're going with this. So we're at the second step. Just as a little note, like the steps start getting a little bit faster as we go. Alright, so intent. How do we make this happen? How do we take an intent, generate it, and then send it to the model? Kind of quickly, right? What is a model first? Because we haven't talked about this. So I need to show you a little bit of the theory behind the model before you sort of understand what an intent should look like anyway. So we just want to keep account of the upvotes for the two emojis, right? So data classes are what we're going to use in Kotlin. Why data classes? If you remember, I made a big deal about immutability at the beginning, data classes are immutable, thankfully. Good, convenient, right? So this is the data class we're going to be using for our example. So the question you might have, if you're not super familiar with this stuff, is, Étienne, this is immutable. So what happens when you increment by 1? Can't increment to, obviously, right? It's immutable. So Kotlin gives you the copy operator. With the copy operator, what happens is that you're going to take the immutable object that you have, you're going to change 1 or 2 or how many ever things you want to change about that object in the copy call, as so. So here, we take an old state that we have, we pass in thumbs plus 1, so we're just overriding the value of the previous one on the new copy. So first object is still immutable, nothing's changing about it. We're just taking it and building on top of it, creating a new immutable object that will have the right count in there. You repeat for each click, and as you can see, things will increment, and life will be good. So that's at the very core of it, how an immutable model and updating an immutable model works. Right, so now we sort of have enough information to understand how to create an intent. So intents are doing very much the same thing I just showed you with the copy function. They take an old state, make something happen, and create a new state with it. Very simply. Now we keep that super abstract, and we call that function a reducer. So a reducer takes an old state, creates a new state out of it, and that's that. It could be the same state, whatever, we don't care. But obviously when you're creating intents that make sense to increment the counter, then you can take an old state and increment it. So if you want to do an intent to add art, it's very much like we've just shown, you use the copy operator, and you add a value, you add 1 to the previous value, and so on. Right? So once you have that, you can take your view events and turn them into those specific intents, and that's the mapping that you're going to need to do. And you can use the when function, when operator in Kotlin. That's the nice thing here is that the when will force you to handle all the possible view events. So you can't shoot yourself in the foot with this. If there's an event that's not handled, Kotlin's going to go, hey, you forgot something, right? So that's kind of neat and practical. also forces if something that sort of enforces the fact that if somebody comes in and adds new events, you're gonna have the compiler yelling at you effectively until you fix that and have the whole propagation chain built. Cool. So given all this is what our intent factory is gonna look like. So you recognize the toIntent function at the bottom there, and then we have a process function. The process function is what's going to take the events, call the mapper, get an intent out of that, and pass it along to the next phase, which is the phase where we take those intents and we apply them onto our data model. So the process call here, toIntent here, the toIntent is called, we get the value back, we call process, and we move on to the next step. Cool. Model store. So here I'm just showing you the basic idea behind model stores. I've already shown you the data class that's going to be the state in this model store, the state source, model state store. I never know how to call them really, but you get the gist of it, right? So a model store, what is it? It stores a thing, type S, generic here. It processes intents to modify that S, whatever that is. And then the output of this is a model state. So model state here, the function returns a flow. So if you remember a few minutes ago, I talked about this idea of the component that has as an output a stream. So I'm formalizing that here a little bit. I'm also saying, hey, this component has an input, which is a process. Now, if you start thinking back to the whole functional and reactive thing, this is really what it means at the core of it. It's functional because it's like a function. You call process, you pass stuff in. It's reactive. That really means that the output is just not just one value. The output is a stream of values. And that's where the reactiveness comes in. Because you subscribe to that, and then you chain things along. Cool. So that's our interface right there. We have our process. What are we going to do in that process? So, right. Yeah, sorry. I lost for a second there. All right, so we're going to be looking at two pieces of this. We're going to look at the input side and the output side, and then we're going to talk about what's sandwiched in the middle. So on the input side, there's this idea of the channel. So I created here an intents channel. So what is a channel? A channel is effectively a little bit like a blocking queue, except it doesn't block. It's suspense, right? So whenever you call a channel and you offer value into it, what's expected is that that's a way to communicate with another coroutine at the other end of it that's going to receive that value, right? So the name is kind of well represented of what happens here. So we're only looking at the input side of things right here. So in our suspend process function, we're going to call the intents channel and send the intent down into it. Straightforward enough for now. So you see again, there's this little icon that says this is a suspend function. So if you're familiar a little bit with coroutines, hopefully you are, that means that this will call and suspend until somebody else on the other side consumes it. That's also a thing with channels. The specific type of channels is configured that way. I'm fuzzing a little bit of the details here because it's kind of late and we'll all have a bit of attention span, right? Alright, so to set up the other end of this, the output side, we're going to use something called a conflict broadcast channel. You all know what that is, right? There's a lot of words there. So the channel, I've already somewhat explained what it is. There's like an input side and an output side. It's a way for two things to basically sync up and just like make sure that value passes around, right? Those two coroutines are going to be able to talk to each other that way. Now it's nice if you only have one of each. What if you want to have one thing that broadcasts in and then a lot of stuff that listens, say like a lot of UI elements that are listening on the model to see an update in their value. So that's where the broadcast part comes in. This is a special kind of channel that can have a lot of listeners, a lot of subscriptions. If you're familiar with Rx, it's a lot like having an observer that a lot of people can subscribe to, share observer, number servers. So that broadcast, or even a relay. Anyway, so the broadcast part is this idea that you have one source and you broadcast to a lot of people. The conflated word, I found it's funny enough, like since I started following coroutines, I noticed that in all the talks I go to, and even casual conversation, everybody started using the word conflate a lot. You can see that a lot of people looked it up in Wikipedia and all of a sudden, conflate, I will conflate these concerns. And anyway, I find it kind of cute. So conflate only really means in this case that if something comes in, like 5 things come in, and you just come in at the last step, everything else is going to be dropped to the floor. I'm not going to replay all this stuff for you. Conflating basically in this case means you get the latest available value. If you weren't there when something came in, tough, right? That's actually what you want when you think about states and updating states and coming in at some point. You just want to find out what it is right now. You don't want to find out how it was 5 minutes ago. Cool. That's the whole word. We've done it. So the last thing to notice here is that you can take that conflated broadcast channel that we call store and call the function as flow on it. We're back into sort of known territory. So this gives us our flow that we will be able to collect on and subscribe to later and listen in on. Cool. My animations are smarter than me. They remember what I'm supposed to say. Alright, so we have these two things. We have the input, the output. What the hell are we going to put as a sandwich in between? Well, there's only this one line to explain. So I'm going to reassure you right now, we're not going to be sitting here for another hour. So it is a dense line, though, so we will go through it click by click. And then I have like the fanciest animation I have ever built on Keynote. This animation is the result of hours of work. So hopefully it'll help you understand what's going on. So we start off really with our conflated channel at the bottom. You see I highlighted the starting state right there? So the thing to note is that this thing that broadcasts to a lot of people, it starts with a starting value. What is that starting value right now? It's two empty counters. The two counters that are 0, 0, and basically that's where we want to start, right? So when I call this originally, I will initialize it with a data class that has 0 in both variable values. Now, once I have that, and the user clicks the up thumb button, right, what we're going to see is that intents receive is going to activate. If you remember, intents is this channel that's waiting on something to happen. So this function that we're seeing a sandwich in the middle is basically calling that intents all the time, just waiting on stuff. Whenever a button click happens, intents receive will resume and give us an intent. Yay. So we can take that intent and call reduce on it right away. And what does reduce do again? It takes an old value, which in this case is whatever value was in the store. So what we're doing right now is taking the current value, which is 0, 0 for our data store, and we're passing it to the reducer, the reducer function on the intent. So in this intent, as you remember, they're defined to be matching the view event. So if it's +1 on the value, that's what's going to increment, and if it's +1 on the other, that's what's going to increment, and that new state is then going to be passed on to the store offer. That's our broadcast channel. Meaning that anybody that's interested to find out how the model has changed will now get the latest copy of what's going on. And we've incremented the counter thumbs up by 1. You will keep applying this sequence over and over and over again, and you have your model store that will reduce these intents, apply those changes, create your immutable state, send it over to whoever's interested in that. And this is actually, I think, the most complicated part of that whole talk. And the strongest, I think, idea that I usually want to communicate in this talk. Cool. So once it's all said and done, this is what you're looking at. Now, spoilers, there's better ways of doing this that are coming. I went over this with a few rulers at the DroidCon yesterday and Monday, and they stared at it for a while. I stared at it, and I was like, you guys think this is stupid? Is this going to work? Coroutines? I'm not super familiar. In RxJava, I got this nailed. Like, I have another talk where we covered this, but I was very suspicious of this. And I got thumbs up all across, except somebody went, oh yeah, but wait, that's funny, that's exactly the PR they're working on, JetBrains said. So there is something coming that's going to take the conflated broadcast channel and rename it into something that is going to be either data flow or state flow. I voted for state flow. I went on the GitHub today and I voted for state flow. And then if you think about state flow, and you look at this, you're like, oh yeah, this whole thing should be called state flow, shouldn't it? And that's effectively what we're going to get. And I think I saw the PR. I have to review the code. It's going to look a lot like this, except maybe with a sandwich line that's a little bit more well-crafted. So this, if you look at the init block, that's what's sandwiched in, right? So what we do in the init right here is that whenever we start a store, the first thing we do is we launch a new scope and we loop over the intents receiver and just get all the intents that we can. And that's all we do. And we only activate basically whenever somebody sends us something. Last little bit that's worth noting is the close at the bottom. The close at the bottom is what's going to clean up everything. I'm not going to go into detail on that, but that's just like the only bit of complicated stuff that's going on here, really. Like, to be aware of how coroutines work. If you're new to this, like I was like 2 weeks ago, this might seem a bit confusing, but well, given I've sort of understood how they work in basically 2 weeks, and I'm not that specifically smart, I think it's going to carry over for the long term that everybody's going to know this is in a year or two from now. All right, so when it's all said and done, and you've defined what I've just shown you, which was generic, by the way, if you notice, the definition of a new source is the 1 line or 2 liner at the bottom right here. So whenever you want to create something, in this case we want to create an upvote model store, all you need to do is give it a type and an initial value and you're done. Cool. Just like so. And we're good to go. So, I told you that these were the harder bits. It's going to get simpler from now on, and it's going to be fairly quick. So, we have our model down solid now. We need to figure out how to hook that up to our view. How are we going to take... There's an observable in this thing. Holy moly. I'm besides myself. I've looked at this deck easily 30 times to find every instance of this word. Evil. Right, you didn't see it. Nobody saw it. Cool. It's a flow. It's a flow. It's not an observable, nothing to do with it. So, once you have your flow, what do you do with it? Well, right here, the first thing I'm going to do at the top right here is create an extension function on it. So what I'm doing here is I'm just basically defining a little blob of code that knows how to take a flow of this specific type and update my UI. What's my update? It's super simple, right? Like all I'm doing right here is updating this string, right? Straight up. And I'm taking my state, I'm updating my numbers, I'm setting that into my counter text view, and that's it. How do I do this? How do I subscribe to this? We see at the bottom of the input section. We take the upvote model store, which in this case is an ASCII singleton. In your system, it should be a singleton backed by a DI or whatever. That's your poison of choice. Then you call the model state function on it, which gives you a flow, not an observable. And then you call for counter text view on it. And just to make that all activate and happen and be nicely subscribed in your scope, you call launch and scope, and you are done. Cool. 41 minutes flat. That was the time I was allotted. Thank you. I'm skipping the live demo. No live demo for you. So this is a lot of stuff, especially if you're not used to all the reactive Django and all this. It's a very small project. It's here. Upvote. Now/upvote. Yes, you can. Can somebody show the young lady with the back of this? Thank you. Put on your shoes. I'm going to need to wait a second until she puts on the shoes. Cool. So yeah, upvote the project. It's actually super tiny. Very easy to sort of grok, play around, mess with. I have a lot of URLs in there for material I found to sort of make me learn coroutines. What I was trying to say earlier about coroutines, me learning them in 2 weeks was not a brag or anything like that. It's really like, if I can learn it in 2 weeks for presenting and making some sense of it and telling me, having people tell me, oh, I understand what it's going on, you can definitely learn this stuff too. Like everybody can, for sure. So that's the first thing. Second thing is, your working project usually fun. You can put breakpoints in there and just see what's happening. And you can also see that you're going to be able to see that there's a few test functions in there that have a ton of output that can sort of give you an insight as to how many coroutines are created, what layers are they play around with scope. So if you want to mess around with that, it's a nice little sandbox to just throw your ideas in there and see if they work or not. And I'll be adding more to it. That's about it. And thank you. More applause, please. Thank you, Étienne, for being here. So last thing, I'm stretching my time, I'm sorry. I just wanted to show a few links. Wait, not that. Right, first big link. I was talking about State Flow earlier. So right now it's called Data Flow to PR. They voted on State Flow like yesterday or something. I think it's going to be called State Flow by the time it ships, which is probably why it hasn't been merged yet currently, which is what I was told. Second big thing, and that one is kind of worth it. The whole bit there where I'm doing the view clicks and the flows and the channels and all that crap, somebody made everything happen. I mean, like, this is Rx bindings for coroutines and flow, and it's not important that I wrote it, but he put it up on Reddit saying, use this and leave me alone, effectively. So use this and leave the program alone. And that's for me for real. Thanks again. Yay.